Welcome to Brain Vision.
Okay, so this one was a little bit confusing as to how to set it up, but I think what they're saying here is that we have a vertical wire. So if we just imagine ourselves on Earth, this is a wire that's standing straight up, pointing up to the sky and then down to the ground. And so it's carrying a current downward. And so looking from this perspective, then we know that'll be making a magnetic field that is out of the page. And so we have a compass that is south away from this wire. So here's our compass over here. And so from its perspective, then we have the wires to the north. The compass is now pointing south. And then as drawn here, out of the page, we have west. Into the page, we have east. So that means then when the magnetic field is coming out of the page from the wire, that means it is coming in the west direction with respect to the compass here. So now we want to draw the fields that are acting on the compass and then figure out what their total direction is. So we know then we're going to have a magnetic field from the wire in the west direction, so B wire. And then we also have the magnetic field of the Earth. And we know that always points north, at least when there's zero declination, as they tell us. So just the north direction, we have magnetic field of the Earth. And we want to find what angle the net field is pointing in, or rather what angle the compass needle will point in, which is the same thing here. So we could define the angle in a lot of ways. Presumably the net force is going to be somewhere in the middle, so B net. And let's find this angle right here. So we know the value for the Earth's magnetic field is just 4.5, I think they say, times 10 to the minus 5th Teslas. And then for the wire, we know that's always going to be mu naught times the current over 2 pi r. And they give us I and r to use here. And so we can find that that'll be 4.78 times 10 to the minus 5th Teslas. So now we have these two components. And so we just want to find what this angle will be here. So it looks like we could do, for this angle, we could do tangent and get opposites. So this would be with height equal to the Earth's magnetic field over adjacent. So inverse tangent should give us theta, and that'll be opposites magnetic field of the Earth over the adjacent magnetic field of the wire. And so we plug in those values and we get 43 degrees. And so that means the needle then will be 43 degrees, and we would describe this as north of west. So north of west.